Okay, well, let's see. Where's this? Nabiyotam Crater, Kenya. Wow, very nice. The volcanic caldera. Wow. Okay, how much to get there? 6,000, bruh. Wait, hold on. Pri per what is PPS? Per safari or what? Whoa. Means what? In tourism. Per person sharing. Wow, guys. This is crazy. What do I actually mean by per person? Okay. Wow, that's a lot of money. Nothing to do about that. Okay, and start. Okay. Yes. Okay. Here. Uh, this here. All right. So each worker can only do this difficulty. You want maximum profit. So 7 can only do these. And out of these, 30 the max. Right. So which is 6. Right, 6 can only do these. Same. So 30, 30. 5 can only do 4 here, which is 20. 4 can only do 4 here, which is 20. Okay, so first we gotta find, for every worker we gotta find difficulty, right? So which means that we can do for each worker we bisect left, which is no, bisect right, right? Python bisect left and right example, provided we sort them. Zero, 1, 2, right? So bisect right is 1, 2, 3, 4. 0, 1, 2, 3, 4. Right. Okay. So the approach will be for each of these worker we get to find the lowest number, the maximum difficulty we can do, and out of these we're gonna find the max. So these is linked together, right? So we got a sword. For each of these number, for example 7, we want to find is difficulty sorted? They're not sorted. So for each of the worker number here, we gotta find the max difficulty, and then that will be the upper bound in the profit, right? So then we gotta find the profit as well, right? So first we gotta we also need to sort both of these, right? So in this case sorted. So once it's sorted, right, we so in this case it just happened to be sorted, right? We gotta sort them in because, for example, this number right here, you want to find the max difficulty with the max profit, right? So how do we filter them without, is there a way to, let me write down. We want, so whatever the worker that we pick here, we want to find the index the max index. So basically the min index to the max index with the difficulty I in the 0 to the worker I, right? So we find that, so out of these index we will find the max out of this index, the max profit, right? So how do you do this? So let me they should really give better example, right? So let's in discussion is there an example? Let me see. Cascade, nice, thank you. Let's give some of the example, guys. Is it a good example? Okay, so we have 68, 35, 52, 47, 86. This is the difficulty, and profit is 67, 17, 181, 3, and the worker is 92, 10, 85, 84, 82. Okay, so if we sort the difficulty, we also have to sort the, so basically instead of this we want to map the profit to want to map difficulty to profit, right? So we have 68 to 77, right? So this is 68 1 0, 35 0 to 17, 52 2 2 1, 47, 47, 3 to 81, 86, 0, 1, 2, 3, 4, 82. So now we have 92. So 92, the max profit we wanna, okay, worker 92 can choose any of these, and we wanna choose 86, which is if we sort this, we're gonna have 35 1 and 47 3, 52 2, 68, 86 4. Okay. So basically 92 wanna find, basically we just wanna find 92. So we just bisect a left, right? So we will find 86, right? So okay, but 86 here, and then we need to find uh the minimum, right? So the minimum here give us difficulty is 31, 35. So basically in this range right here, 35 to 86, which is giving us 35 profit of 17 to 82, right? So now we gotta have so first we sort the difficulty, but we need to have a pointer back to, we have to have a pointer back to profit. In this case, somehow we need to find um, so 35 is 17, 47 is 81, 52 is 1, and 68 is 67, 86 is 82, right? So we have to search two layer. The first layer is we want to find in the first list. So and then we have to search in the profit list, right? So 86 give us right. Can we somehow sort two layer? Hmm. So the first layer after we sort is n log n to find them, and then this give us um, 35. So if we can somehow do another m log n, that'd be great, right? We have 35. What does the guy give in the discussion, the test case say? What is going on? Why can I not scroll? What? Oh, step on something. Yeah, so if we somehow can figure out a way to sort by 2 layer, then that'd be great. So for example, 92 here, you want to quickly find the range, right? The range here is 35 to 86, right? So does it, if we don't sort them, right, we look through, as we look through this, so basically O n multiplied by difficulty and profit the same, right? Okay, so this is basically ln squared, right? Which is not good. If we can somehow quickly find, for example, 92 here, it's go 35 and 86 here, right? Then so the other approach we have is O n log n, right? So from 92 we can quickly find the thing, right? But then we still have to loop to find the max, right? Which is O n log n, for every n, for every m, we have to do a search, right? Oh, m log n, and once we do that, we still need to loop from the range, right? So which is some sort of k, right? Is there a way to find a solution faster than that, right? So once we found 35 to 86, how do we know the largest profit here? That's the number one question, right? um um let me think about that. But that's a scenario we can always do, right? What if we also sort the worker? Hold on, let me see if we can do that. Okay, so if we sort the worker, which means we have 10 82, 85, 84, 85, 92, right? So first thing we gotta find difficulty, right? So difficulty will be, we got this, we got 80, 35, 47, right? 52, 58, 86, and of course 35 is actually mapped to 17, this profit. 47 mapped to 81, 52 mapped to 1, 68 mapped to 67, 86 mapped to 3. Right, so first is the 10. Yeah, so 10 will find the difficulty is actually 10 cannot find nothing, right? So that is 0. Okay. Then we got 82. 82, according to our binary search, it will find us in the range of 35 to 86, which give us the window from 17 to 3, right? Right, so this give us, we just do a loop from 35, so we have basically a difficulty of 35 to 86, right? So this give us a window of 35 to 86, right? That's mapped to the range from this to this, right? So out of 17 to this, we found that 35 to 86, the profit max will be 81, right? So in other words, if we remap profit, we will find 1, 3, 1, 3, 17, 67, 81, right? So if we can get 35 to 86, it should give us 35 is actually 0, 1, 2, 3, 4, right? So somehow 35, 47, 57 is 68. 1 second. 3 is 6. 1 is 52. Right. So we can find 35 to 86, which is 35 is mapped to 0, 86 mapped to 4 here. Is that correct? Or do we still have to loop? We want somehow from 35 to 86 here, 35 map to 17 here, 86 map to 3. We want to find the maximum profit, right? We could easily loop them, right, to find them, but can we do a OM log n and then log n, right? Is that possible, right? Because if we do a search on the second one, right, we can do ON log n for the first difficulty, and then it's gonna be n, right? So the solution will be mn log n, right, which is worse than OM log n, right? So if we can for sure we be able to sort the profit, but if we can find the max within that range, that'd be the best, right? So if we can somehow map let's just first implement the first solution for mn log n, right? So basically we have to sort difficulty here, and basically once we sort difficulty, right, so difficulty equals sorted, right? We have to map so basically we call this difficulty profit was sorted of for I in range of land of difficulty. Okay, so we would have a tuple of difficulty I, profit I. Right, we sort by difficulty. Right. Right, so and then what is it? Profit. Max total profit. Right. We're gonna return max total profit. Right, so for worker in for W in worker, we gotta find this value in the difficulty. Right. So and then we gotta find the index in the, so this is bisect left of what? Bisect left of difficulty profit, right? Does it let me use bisect left, or do I have to implement the bisect left? Okay, bisect left, this give me an array, right? So bisect left will be difficulty profit range. This call is DRPPR, right? Just give me from the beginning difficulty profit beginning to this one, right? So this give me the what is it? What do you bisect left and the value. Gotta find the value, which is W, right? Right, in Python bisect left on array of tuple. Okay. This guy take the, is this possible? No. Oh, you can do this. So comma. So this, right? I want to compare the difficulty. This, right? So basically, if PPR, then max total profit plus go to max up is PPR, right? So this give me a difficulty in profit. We still need to find the max profit, right? So the max profit here, we still, let's just loop them, right? For whatever this is. So max equals 0. Profit in DPR, right? Max profit. So max total profit gonna plus equal max profit. Okay, what's wrong here? 80. Okay, so first let me find if we did it correctly. Print difficulty. And then for each of this worker we print them out. Right, print W. And we get back the array PR, and then we print max profit. Okay, is 2 what this is difficulty 2 is wait, hold on. Difficulty 2 map to 10, 4 map to 20, 6 map to 30, 8 map to 40, 10 map to 50. Good. So we're gonna find 4. Right, we need 210. Okay, missing something. Okay, do we do bisect right then? Right, still find 210 plus 1. $210, $420, good, because we want to find 4, right? So that 20, good, and we want to find 5, and it's still finding this, right? So let me write most index. Let's do this. Maybe this, right? If DPR, what's this? Difficulty profit RMI, let's just call this RMI. If this, if RMI, if this difficulty is 0, equal W, then keep it. If not, then 3 minus 1, right? If so, like in the case of this 0, 1, 2, it found 2 here. We don't want to include it. So 0, 1, 2, right? So we want to 0, 1, right? So 0, 1. So with the equal, we want to include it, right? Else right, so then it will be this, right? Okay, so 4 we got these 2, find. So bisect right will find the rightmost, would be this. Or if it is actually equal to W, if it's equal to W, then we got this, which is 20. So first let's see what is print first. Okay. W is 4 and this is 1, so it found it, right? If it found, then you want to plus 1 because we want to include that. If it couldn't found the 0, 1, 2, which is this one, right? So we still want to include them, so that means we don't do this. Okay, see how do we do. So basically I think this is actually comment give O up M log N O M and log N, right? If possible to also log N on the profit, that would be great, but we will try to see if it works. Right. Okay, submit. Let's see. What? Index out of range. So, okay. What is this test case here? Let's do this. Oh, what is this? And this. So 134, we got this. Good. We want 73, which we get this. So 0, 1, 2, right? And 3. Okay, so if RMI is greater than the length, greater than equal to the length of difficulty profit, if RMI is less than length of this, that should fix that. Right. Okay. We submit again. Okay, submit. Uh-oh, nothing wrong. Wrong answer. So let's see what is wrong about this. So we have this. Okay, we want to find 95. We want to do it to here. Very good. We expected 553. We want to find 46. Is good. 47. Also, maybe if we can find, right, you see, if we can start from the small number, right, then maybe we will cover the thing later on, right? Because right now we keep having the range, but let's figure out if we, where does this go wrong first, right? So okay, 46, good. So profits is okay, hold on. So max profit, it's saying in this is 87, good. 37, good. 47, no, 60, good. Instead 47 and 0, 1, 2, 3, 4, 5, 6, 7. And then 97, right? We got 83. Oh, something wrong here. We want to find 11, okay? If we want to find 11, we couldn't assign him anything, right? Okay. So, okay. 35, good. 35 is 20. Wait. 35 is 20 here. Right, okay, okay. This is one part that is wrong. So, we want to find 35 with 0, 1, 2, 3, right? So it keep 2. Keep 2 here. So something is not right. Let me CMD here. Let me look at the bisect right here. So we have basically right. So if we do by LF from the beginning to bisect right of L, and because we have a tuple, we pass, we care about just, we want to find what do we want to find? We want to find 35, right? Oh, what? From bisect import bisect right. What? So L is this. Wait, hold on. 98, 95, yes. Okay. So what does this give? the first thing. 2 0 1 2. Not at all. What? Okay. So Python bisect rightmost element, right? Is that how it is? 0 1 2 3, right? 0 1 2 3 4, right? So which is the left of that? Python bisect right array of tuple, right? We can compare that, right? Only consider the first, yeah. So this is what I did. 0 1 0 1 2, right? It didn't find this, right? So if you do 5 here, it should give me this 5 7, right? Now this is the rank for 5 7 5, therefore 0 1 2 3 4, yeah. So think 0 1 2 3. What the hell? Okay, so why does it not find 0 1 2 3 3 here? Okay, so what does bisect left does? Isn't that it also give me 2, right? What? Yeah. How do we make it return this? Right. Okay, Gemini. Where's my mouse? Okay. Why does this not return 3 or 4? Okay. This will be this. And explain. Explain to me, my AI. You get what? Okay. So bisect right, return the left most insertion point. Is that true? Okay. Let's do. Oh, you can pass the key. Oh my god. Let's do that. Okay. Now 35 key equal lambda x0. Okay, fine. I'll do that. Lambda. Okay. Do this. Check this out. This will be w and p equal lambda x. Just consider the first one, please. Okay, fair. Good, Bob. Did they let you ask Gemini? That'd be cheating. Whatever. We're here for the learning. Okay, let's do it. Uh-oh, still spinning. Time limit exceeded. Oh my god. I knew it. You probably have to. You probably had. They have like, you see here. The worker gonna be like repeating, right? So like. So it's better to, instead of finding them the thing here, right? You want to be able to say that me look. Okay, so let's run out. Time limit exceeded. Oh my god. So it probably make more sense to sort the worker, right? Because if this go like this, right, then chances that there's like what, for example, oh my god, let me think. So if we sort worker, right, in the case that you have like 10 here, you have to maintain first 0 to, what's that, 35 to 86, right? So if you go to 82, right, we take a look at our, okay, so Our difficulty is ranging from what, 35, 47, 52, 68, 86. Yeah. So we want to maintain this window. Right. So now the next one is 82. Right. $82 we gotta find. Right. So if anything greater than 82 we're gonna discard, right? So in this case we quickly know to get 68, right? So okay, in other words, first we gotta find the max one, the max worker, right? So 92 here, we could carve out 35, 47, 52, 68, 86, right? So first we gotta ask, okay, this is the max we can do, right? And then we go to 85. Okay, hold on. And the 35 to 86 actually map out to 1781, 167, and 3, right? So this give us 81 is the profit, right? So we still need to 81 here, right? So now we want to find 85. 85 we move back to 68. So that gonna still become 81, right? And then 84 is the same, 82 is the same, and then 10. So we move this back to this. So when we move one pointer in the difficulty, we also shrink the number in the profit, right? So we think, so we started from the biggest. So in this case we have 92, we found 86 is the maximum that we can find from the difficulty. Now 86 basically carve out to the second array to be in this range. Okay, so in this range the maximum profit is actually this number, 81, right? So we still have to loop through and get it from this number. And the next one we find is 85. Okay, we say 85. Is this less than the last number? Yes. So we keep moving until we find the number that is the graded number less than that. So because the last number is profit still within that, then we do that. But does it not get it? It doesn't guarantee that. Because we sort two-dimensional here. Right. So when we do 85, the number difficulty has to go to 68. Oh wait, hold on. One thing we probably can do. Can we just cache this number? Because do they ask for a lot of worker, right? So let me look at this number real quick. Oh my god, what are these? Okay, this is worker. So if we sort worker and go from the max, that will, every time we go from the max, we move the index difficulty down, and then when we move the index of difficulty, we also want to move the profit, right? When we move the profit, so 45 is 15, right? So we can try that. So basically first got 35, 17, 47, 81, 52, 1, 68, 67, 86, 3. When we first asked for 92, right, we found the number is 86. Okay, yeah. And we gotta find the max. In this case, it was this number, was 81, right? So as long as the profit pointer, so PP, is less than is still less than the difficulty pointer DP, then we don't have to move the PP, right? So okay, first one is 92. Good, found this, gonna be this, and then we look at 85. Let's move. It's still greater than that, then it's still 81. Good. And then we do 84. This number is still less than, so it's still 81. Found 82. Good. The pointer doesn't move. And then we found 10, right? So now this 10 give me move back the pointer, which is give me this, which is number this, is less than the last one. So then we need to okay, let's try that. Okay, so first we gotta also sorted worker, sorted worker, right? So now we go from the begin from the end to the okay, so gonna be I equal land of worker minus 1. So yi greater than equals to 0, right? bw is equal worker at I. Okay, so first we gotta find the w in this difficulty profit, right? So which is right, so we okay, so first we find the number which is RMI here, right? So we don't want to okay, so let's do, we only want, okay, let's just do some note here. Only search if the so basically we need to find the 2-pointer first, right? So basically let's name them what? So we profit pointer equal negative and difficulty pointer equal -1, -1, right? So first we gotta find, right? So if profit pointer equal -1, right? Hold on. Difficulty pointer equal to -1, that means the first value ever, then it's gonna be this, right? So if dp is this and dp0, whatever it is, right? dp, right? So that so after we find dp, we need to find the pp, right? So pp gonna be equal to we need to, for now let's do loop, right? Okay, so we do dp, right? So okay, so the outcome of this is we will know the, maybe we put a point, maybe there is minus here somewhere, right? So j So this is like I minus 1. So like yj is then equals 0. Oh, j equal to, okay, so pp is actually equal to dp, right? Length of dpr minus 1. So y pp is greater than or equal to 0, and difficulty profit of minus 1, right? pp minus 1 is greater than max profit, right? And then it's greater than, we want the max, right? So pp minus 1. Here we go. So along this process we could also do minus 1, right? So we basically loop back until we found the maximum profit. If after this, if pp is less than 0, then actually 0, right? Okay. Else, okay, so now dp point to here, right? Let's say we want to find 92. We got this, so that's the beginning to this, right? And we found this, right? Then the next one is we found, it's okay, LF pp is less than no dp. So okay, so if dp is, so if, as long as dp greater than that, we don't have to update pp, right? So okay, so if dp is basically less than pp, then we need to update the new pp, right? So basically, right, so, and the other case is else, that means dp else lift, that means greater than or equal, right? Greater than or equal. So dp greater than or equal, then so that implies that we always need to get this dp, right? And then we do all this stuff, right? And we just also use this test case and see if we pass that, right? So here we say if dp equal to -1, right? or basically PP is greater than DP. Then basically we need to update PP, right? Right, like that. Otherwise it means that the profit will always be max profit. So basically max total profit plus equal to, what is it? Let's do this. Right? Okay. So this is gonna be equal to BPR PP minus 1, right? And if it is in this scenario, then it will be this. Plus equal to max profit. Maybe. Oh. Index out of range. Right. Okay. If DPR, what about that? Ooh. 13, 35, what is it? What cases? Okay, so let's print this. Debug this. And right now we have DP. Okay, so we have 13.4, 37.90, 58.69. So we want to look at 74. Oh wait, we want to look at 73, 45, and 34. 73, yeah, we 0, 1, 2, we got 3. 0, 1, 2, 3, right? 0, 1, 2, 3, what? And okay, hold on. 45, we got 0, 1, 2. Wait, why do we got 3 here? We search for the W here is 73. This is difficulty, which is 2. If less than, then okay, it's not including that, right? So we should print the DP. Okay, we got this. 45, we got this one. And we also want DP here. Okay, so the max profit is what? Should be 96, right? Which is this number, right? So PP and be greater than or, then we search for the max profit here. We start from this to the end, right? Oh, we need to keep the max profit index. Okay, so PP and difficulty is greater than max profit, right? This is greater than, good. This is also greater than. Okay, so basically we do this, right? And max profit equal to, this said that this one. Okay, what is the constraint here? Profit, oh, greater than 1. Okay. And so if max profit equals that, or check this, right? So let's run this. Why is this still 1 0 1? The first one, right? So we might be looping back. So let's keep this, right? And we start at this length. Oh wait, hold on. We shouldn't cut this like that, right? It's just gonna be that we should do not filter, because this will remap the size, right? We just wanna do the thing, right? So let's keep a difficulty here, right? Okay, so we start at what do we start at? We start at DP. Length is that, otherwise okay, this give me the right most index. If it is equal that, else mean either it's greater than or is not equal than dp minus 1, right? Because now we're not going to do the remapping the size, right? We always gonna do is we start at dp and okay, we keep going down until the profit is okay, hold on. We start at we want to keep going down until we find the max profit, right? And so, we have to keep the element of the max profits. Okay, so let's call this MP and MPI. So the negative one, right? So we put do we use the I already? Yeah. So J equal to DP. Yj greater than. Okay, so basically we can actually loop, right? For I so if max profit equal -1, right? Or whatever the number here, profit is greater than max profit, then gonna be equal to that index J here. So J, and what is it? Whatever this is, profit in difficulty let's just do Yj less than DP, right? So J plus equal 1 here, right? In here we got whatever this is, profit equal difficulty profit, right? Of J. And let's see what that. So if all profit greater than MP, then MPI equal to J, and max profit equal profit. So we get out here. So basically we got the index of BP equals J, right? So yeah. Oh. Oh. Otherwise max profit just gonna be difficulty profit up PP minus 1, right? Oh, okay. So at least this case is not entirely time out, but what happened here? Okay, so what's wrong here? Yeah. So W is 7, we're looking 7. We got 2, 0, 1, 2, good. 0, 1, 2, good. Then we gotta print the profit. So profit is other Y also want to print the profit here as well. Okay. 0, 1, 2, right? 3 plus 7. Profit's gonna be, oh, has to be 30. Okay. So let's print the, regardless, let's print the PP is true. 0, 1, 2. Yeah, so it should be okay. Regardless, right? We can do this, right? Basically, oh, no. PP here is MPI. Right? So that's gonna be, so this is basically this outside here. So we can just do, we don't have to do this. Right. Okay, let's check. Okay, profit 20 here is wrong. Oh, this is less than or equal, maybe. Okay, so at least we passed the time limit exceeded. Looks like it's a good optimization. But what's wrong here? Okay, so looking for 40. Did we found them? No, and we still give profit 24. That is wrong. We need to do the case where we couldn't find them, and profit is gonna be 40. So 40 here, DP here is -1, right? So we gotta do if DP equal -1, then we continue, right? We don't want to do this. What's going on? Oh. If DP is this, then we still gotta do I-1, right? Okay, right. We will see, my friend. Let's see. Let it pass. And we might have to come back to this and optimize it better, but this will do. This one doesn't exceed it because here's the thing, like we don't want to like look for this, update the max profit all the time. We just want to do this mid. Let's see. Oh, this look good. Okay, it passed. Not bad. Okay, so this is solution 1. So what we did is optimize for not looking for not searching for profit all the time, only when it needed, because chances are um, there might be not that frequent, right? So another thing we can do is we can cast the profit, right? So let's do a cash here. Profit cash equals this, right? So once we found the profit for this value, right? If difficulty, okay, so profit equal, right, if profit not in profits cash, right, then we add them. Profits cash up, oh no, W, right? So W is not in equal to profit, right? And so first thing we do here is, maybe what we can do is, if W already found, W is already in the profit cash, and we just return that, right? So this will be I minus 1 and continue, right? So basically here plus equal to profits cash W, because chances are there's a worker that have the same difficulty, right? Let's run this. Okay, submit. Let's see. It's better than, a little bit better. Okay, it's not a little bit better, but not by a lot. Right, so cast same number of difficulty. Right. Okay. So well, let me think for 5 to 10 minutes or whatever, and we probably have to come back tomorrow to think if we can optimize it as to be whatever possible to do m log n or something, right? But we got the solution, even though it takes some time. Let's just at least commit this to our GitHub. So what is this? This is most profits assigning work. Okay, made the GitHub profit assigning. Yeah, this one right here. So we gotta do most profit assigning work. I know there's a login solution somewhere. I just don't know how to do that yet. But the good thing that we at least we learned is that do not fret when the time limit exceeded, guys. See if we can optimize bit by bit. We should be fine. Okay, so from bisect. Oh, it's like we should implement bisect right, but whatever. Let's do that for now. Bisect right. So from typing port list. Should do it. Okay. The description is so they want you to do. Let's see if we have that in our daily. No. This is hard. 1174. Okay. And they want you to do another medium. Okay. Okay. And we look back. Oh, not this one. Okay, copy this. Ooh. But at least we solved it. We need to see if we can somehow figure out if it's possible to, like, instead of always bisect right, we technically can look at the previous DP and look back whatever, but this is and log and all the time, right? And then if we can do this PP, right, another log n somehow, then that'd be great, I think. Okay, but we'll think about that for 10 minutes or 15 minutes, and then we move on to the Kafka, and we'll come back to this maybe tomorrow. And yeah, so what is our runtime here? Not too shabby, not too shabby. Okay, what is... Hold on, who's calling me? Sabotra. What? Okay. We see. Okay, runtime is crazily high right now, which we don't know how to optimize yet. This. Okay. Now, 1, 2, 3. Difficulty profit in worker. Difficulty. Was that? Yeah. Profit worker. So the actual number will be solution dot let's see. If you want to do these, test. Let's pick 100. Python up. Okay. Okay, so let's think for a moment. What we did is we first find the number, right? And we cache them. So right now what we did is we find all this, right? Which is log n. Let me TikTok for a moment. Social break, guys. Social media break, and then we think for a minute, or like if I'm tired, I'll just look at the Kafka, and then tomorrow we come back, think more. Or maybe one of the approach that we could do is, instead of searching this, right, we want to know like if they have some value that really close, then we can just loop back from DP to LP, right? So basically one of the thing we can do here is if DP is not equal to if they asking for the same W, you have cache here, right? So maybe if we do if DP is greater than PP, right? We shouldn't have to do because they might ask for some number that really close to the current DP, right? But DP at least guarantee the log n search, right? And what we did here is we cast the PP, right? So hold on. There's a dog just going around. Nazgul the dog win the Olympic. Oh wow. Bought a house and lot later. Wow, that's crazy, brother. Okay, so think. Mm. Oh, also, if it's possible that basically we loop through this, and if we found something, right? We know. Okay. That is good. That is good idea. Okay. So we have this, sure, and basically we do a max. So we have a profit. So if we found you see here, if we found something here, right? If somehow we know the max profit, then it's good, right? That means we can loop through this thing, and then we push the max here, right? I think. Right? So then we don't have to do this DP and PP here, right? So basically, okay, so for so our difficulty here, we sorted them by, okay, so let's do that. So let's have a thing called max profit by difficulty. Look at this, right? So we sort through for, so basically here we sort the, we just basically sort the difficulty here. We can actually do this, right? Right, so we sort through difficulty dot sort here, right? So for difficulty, right, for D in difficulty, right? So if we sort this profit, come on, is a peace deal in Ukraine possible? From John Mearsheimer. I have to read that later. One idea. Let me write this down, because one idea is that if we found a difficulty, we can find max profit we go through them, right? Something like that, right? Oh, the local code is saved to local what? Where did they save to? With that local storage? Okay. Uh, so the idea here is, if we found this, right? Technically, if we do all the max here up front, then once we have this and we have that, right? So that means if we solve the difficulty, right? Oh, okay. So we want to, we want this, right? Okay. Okay, so now we want to loop through. We want to maintain another one called profit difficulty, right? Okay, for what is it? DP in difficulty, right? Difficulty profit, right? So for this difficulty, right, we want to find the max, right? So for, let's just do, okay. So this map out like similar to what we have here, right? So this, assuming this is a difficulty, then what should be the max profit from the beginning to that, right? So you want to find the index of yeah, so you want to bisect what's that, bisect right of, with the value here is, we want to search this by the thing here, right? So by the difficulty, it gives us that array. So we have to go from the beginning and compare with the second one here, right? So this is MP, right? Right, so basically we bisect left, right? Right. So if MP is less than, is equal to -1 and less than 0, this is MPI. So what do we do here? If MPI so this is the what if we couldn't find the value, right? So Coco -1, then basically the profit is gonna be profit by difficulty of the same index is gonna be append 0, otherwise gonna be profit difficulty gonna append difficulty profit, and what was it? MPI, right? So we look to the left and we want to find the difficulty, and when we compare, right? So basically, okay, so we want to look bisect difficulty profit. Here we want to look all the way beginning to the current index, right? So DI in enumerate of this, right? So we want to look from the beginning to what? Wait, so no. So when we compare, first we gotta compare the difficulty, right? So this is still 0, right? So we got this, then otherwise we want to find the maximum from, okay, hold on, bisect right here. So if we found, so let's say, hold on, we know the difficulty, and we gotta look in the profit, right? No, we have to look in the same one, right? So this one basically from the beginning to, so the difficulty here is we sort by difficulty, right? So now when we look at 35 and 81 and hold on, right? Doesn't the index give us, so we look at 35, what is the, if the question asks 35, difficulty 35, so we want to find the max, the difficulty 45, 47, right? So this give you 17. Why don't the, isn't the profit always gonna be the next one, isn't it? Right? Right, so because if we want, so let's say now let me think about this tomorrow, but let's look at Kafka for now. Okay, let's see. Okay, Kafka at Walmart. My brain is fried right now. What is this? Oh my god. 1 year ago, how Walmart used Kafka for real time. What is this? Long article, bruh. There are videos. Do watch it. Yeah. What? Then oh, what did this do? Is there a Walmart in here somewhere? No, right? Apache Walmart. Let's just read that article then. Okay, remove my stuff here. Okay, 2022 though. Just put this in our node. Okay. Mhm. Okay, what they do? So many messages, man. Phone is a distraction for real. Welcome back. What is this? I don't care. There's another article. What is this? There's so many articles, guys. Okay, let's just look at this one first. Okay. Real-time inventory system. Hold on. Before we can read this, we have to read uh Walmart. Too many messages, guys. Real-time inventory system. Okay, so do they have a database where they give a view or something? Or they put in some cache or something? Because there's no way you do like open that many connection to your database. It will crash it for real. Event streaming, okay. Okay. Item store quantity. we have all the event. You go to Kafka stream and then go to Kafka's cluster. Wait, what? Oh, yeah. So I'm streaming some event. So they split the producer into partition and stream those. Uh, the producer produces message to shard or partition, which is streamed to consumer, right? So okay, Gemini, what is x equal 0 and x equal 1 in Kafka? Producer configuration. Also, this is basically the what was that, the Cassandra quorum consistency, right? Similar. When you set act to 0, producer does not wait for enough from the server at all. So I guess act equal 1. Okay, so basically the leader accept, and then it will replicate, I guess, later. So this probably have a risk of losing data, right? So this is x equal 1. The leader act, the leader confirm, receive, before moving on, right? Medium. But what happened when leader crashed? Does it retry? Oh, so Kafka elect new leader, then does it replicate to new leader when crash leader come back online, right? Latency is fastest. Okay. Okay, so this is similar to consistency level in Cassandra. We have 1. You have quorum. Right? Do you like me to explain? Yes, let's do that. What is this? What is all this message? Shut up already. Okay, easy. Use all for financial transaction. Okay, so nothing we know is 1 or like financial transaction. No data loss, please. Zero for log, metrics, or whatever. Okay to loss, to lose data, right? Whatever it is. Yes. Give me some example. So Walmart set it to 1. Chances are you still lose, no? Where are we? Okay. They spawn another thing. So we'll have to read this next. First, allow only one consumer to read from one partition. Okay, so you have each of these partition has one consumer, one partition. Okay. Experiment and load test to find out the right number. is what they're suggesting. Right, so let's ask Gemini this, right? Okay, hold on. Yes, let's see what is this. Oh, okay, so when you do XOR, chances that you can have duplicate, right? Okay. What about duplicate? Don't your consumer handle that? Right? So they do that with idempotent producer. Okay. Okay. So basically identify by using unique ID. And it's a secret number. We got exactly one delivery. No duplicate. Yes, keep going. We'll keep going this rabbit hole. Okay, so this is go to consumer group. So this is what basically one consumer, one partition here. Consumer A, okay. Oh, so it just round to consumer depending on your partition. Okay. Consumer A crash, then B handle them. Instantly first down. Okay. So basically this is also having consistent hashing behavior. You cannot have more active consumer group than you have partition. You have 3 partition and 3 consumer, everyone's busy. If you add a focus, it will just sit there idle. Okay. You cannot have more active consumer in a group than you have partition. So one group cannot have more than the number. Okay. Okay. So let's open up another one. What is, let's go back. What is Kafka? Okay, fine. Well, suddenly we went to Cassandra. Okay, fine. So store data in Cassandra. There's a Kafka Summit video. Okay, we found the video. Along. What is this? View video, bruh. No, this site is a scam. They want to charge you stuff. Whatever. Let's just read. Okay, so now we go back to this. Real-time replenishment. Where's this guy now? He's a VP now. Is Dollar General related to Walmart? So this guy went to Dollar General. Become a VP. Okay, fine. Okay. So 10 billion message per day. $85 gigabyte message per minute. Is that a lot? How big is 85 gigabyte per minute? And who else handle more than that? Compare between big tech. Okay, where's the link? So link it. Okay, I don't know. Maybe. Oh, is it big? What? This picture is so small. We have Kafka topic to Spark. I mean, whatever this is. Okay. Oh, bunch of Kafka. I can't tell. This is okay, I guess. Good day. I think we'll continue tomorrow maybe. I'm gonna take some break and then play some games. Alright. See ya.